drivers plug into those, those are the ones they're gonna be using. The excuse me, our other chargers are our two portable chargers that I did put a video together on that. Those are also level 3 chargers. In the video, I said they were level 2, but they are level 3. I have to go back in and correct that. Those are 50 amps apiece. Now, one of our buses was at 60%, and it took about 4 hours to get from 60% to 100%. And that was using the level 3 charger. Our buses have 3 battery packs. Each one is 220 volts. And that's how we get our 660. So the two chargers of 50 amp, the Heliox, we got those from Cummins, and but they're made by Heliox. The other two that are out in the parking lot we got those from InCharge, and that's what we're just waiting on our software on those, and then we're going to start running these buses. And I'm going to let you guys know how we feel about them, how they're operating. And as you guys get some EV buses, if you can explain to us how you're doing it and your feelings on it as well, we'll keep everybody informed. So the two chargers that we have out in the parking lot from InCharge, those are the 60 amp chargers. They charge 2 buses at a time. So if you plug in one bus, that bus is going to get 60 amps. If you plug in 2 buses, each one's going to get 30 amps. And that can be programmed. So you can set it up so that if you have one bus that is going to be used more than the other one, that bus will receive more of a charge, or the first charge. However you set it up, it is programmable, which that's kind of neat that you can do that. Ours are set up right now where they both are going to get 30 amps. But it's neat that you can set that up. We did purchase software so that we can monitor this kind of stuff. We got the software for the bus itself, so we can plug in to not only the bus, but the high voltage side. So we can see your stronger cells, the weaker cells, the average cells. So it's just like anything. A weak cell or a dead cell will draw the rest of the battery bank down. So it's important that we monitor that kind of stuff. It shows the charge rate. It shows the temperatures of the cells and the cooling temperatures of the coolant temperature of the batteries, the motor, and the interior. And that's just a few things it does. Maybe we'll get a presenter. We'll have a presentation on this software as we get going here. But this is our findings so far. So moving along, our last meeting was held on June 12th, 2024. This was our DOT roundtable. It was recorded and posted, so please check that out if you want to go over everything that was covered. One of the things that they talked about was that DOT was down 8 inspectors. That was at that time. I know they've hired a couple since then. And they also said that there will be no 12 or 15 passenger vans can be used. That's why we're all using Suburbans. But today's presenter will be Kodie Shamrock with Leonard Bus Sales. He's going to be presenting on SCR systems, the selective catalyst reduction system, and maintenance tips. So the floor is yours, Kodie.
All right. Can you see that full screen now?
I can see it.
Okay. So before I get into all of the diesel after treatment fun, one interesting thing with the EVs that we just learned a couple days ago is they've changed the rear axle differential fluid to a lower viscosity rating or a different type of fluid. And they're advertising that as a 6% increase in range in colder weather. And it kind of was an interesting thing to read because I guess I'd never really put thought into the fact that a sort of gummy or cold, very viscous fluid in the rear end may actually draw down battery range. So interesting to see that they've made that change. Obviously, it can't be mixed with the existing stuff, and if you have EVs, you'll get that information, as needed. But I just wanted to share that, they're constantly making changes and updates to try and improve on the product. So I thought that was kind of a neat little tidbit to share. If anybody has questions along the way, I can't see the Google Meet window on my screen now. I'm only on one screen here. So just kind of jump in and ask questions. I think the big thing with the SCR, or selective catalyst reduction, is that's sort of a very general term that refers to one part of the after-treatment system. But the reality is the after-treatment system starts at the air intake and stops at the end of the tailpipe, and it's really every part of the engine in between that plays a part. Obviously, we can't cover everything in great detail just for timing reasons, but I will go through and kind of give you, some rundown on what's what here. So as far as exhaust system flow goes, we know obviously on the turbocharger, there's really two sides to that. You've got your fresh air intake side. I don't know if somebody could mute. I hear background that's throwing me off here a little bit. Sorry. So, and then you've got your exhaust side, which is represented by the white arrow here. And really, it's two very distinct, separate sides, but all play together and hopefully play together nicely in most cases. So really, when you talk about SCR, again, I could tell you SCR is a single filter really on the exhaust system. It's the last stop before it exits the tailpipe, and leave it at that. That's really what the selective catalyst reduction is. But again, it takes a lot to get there. So we talk about the turbo as part of the system because it relates to what you guys do every day and how the engine is designed to operate. And really, the turbo is not only just for power, for giving that boost that you need, but it also helps determine where kind of exhaust goes when we've created it. So you have, some options. You can either go down the tailpipe and exit, or you can be fed back through the engine, and we can kind of reuse that existing exhaust that still has unburnt material in it and try to sort of do it again. It's really designed to pull as much material out of that exhaust that's usable as possible and not get rid of it. Buses 30 years ago, with black smoke belching out of the tailpipe, there's unburnt fuel in there that is being wasted. And so this system is designed to really prevent that from happening. So obviously we know the turbocharger is tied to the exhaust brake as it is the exhaust brake. So if you've got a 6.7 Cummins, it has an exhaust brake on it. It's really just a matter of, is the switch programmed and installed or not? So really, again, we've got the exhaust side that we're focused on right now. So we have a few different ways to tell that exhaust where it needs to go. Obviously, it's not intelligent making its own decisions, so we need to sort of guide it. And you've got EGR valves, you've got a charge air cooler, you've got a turbocharger, and the turbocharger is really sort of the first place that decides or makes a decision on where that exhaust is going to go based on, the current exhaust temperature, makeup of what's in the exhaust. The turbo is going to be commanded to do certain things. So it does that using a nozzle ring. So the image kind of in the center there with the in-out is a cutaway of a turbocharger. And what you can see in there underneath the in-out arrows is what's called a nozzle ring.
Hey, Kodie, your
yeah.
slides are not advancing.
Oh boy. Let's see here. Which one are you guys still seeing?
It's the first one, September 18th.
Oh, that's interesting. How about now?
There you go. We can see that one.
Okay, we're just going to roll with it this way then. Apparently it doesn't like doing it the other way.
Okay.
Okay, so I'll try to make that as big as possible. So you guys didn't miss too much. It was just the intro slide here, and then just a graphic, another graphic, and then now we're on to this one. So thanks, Dan. So really, what is controlling the flow of that exhaust or sort of where it goes is the nozzle ring that you can see inside the turbo here. So this nozzle ring has the ability to move in and out and basically determine how much airspace there is in this system. So a better way to show this is if I show you a fully closed nozzle ring, as you can see on the right here, you've got exhaust coming out, and that exhaust is now forced through that very small channel and down the basically downpipe manifold exhaust, however you want to call it. And the takeaway with this is that the exhaust is lazy. It's hitting a barrier. So because it's hitting this barrier, it's going to redirect and find another way out of the engine. So by closing this nozzle ring off, it sort of forces the exhaust to divert the other way, which in this case is through the charge air cooler, or not the charge air cooler, flipping my mind, back through the exhaust system through the EGR valve. It'll come to me in a minute. Charge air coolers at the front. I think I said that incorrectly the first time as well. So kind of the example I use here is the funnel. You know, we've got a smaller opening. It's going to flow less than we would if we had a larger opening. So the fully open version, you see on the right, allows the exhaust to basically freely flow down the tailpipe and out. Very little flow restriction, very low boost pressure, and it's really going straight down the tailpipe into the aftertreatment system, which includes the SCR. So the actuator on the turbocharger is probably one of the more common fail points on these, and the reason for that is you get carbon buildup, it burns out the actuator. So this actuator that you see on top of the turbocharger is what's directly controlling that nozzle ring. So it actually takes the nozzle ring that you can see on your screen and slides it in and out. And so that's where that actuator comes into play. It's basically closing off and opening that ring to allow a certain amount of exhaust flow. If you take the cover off of it, you'll see there's actually sort of a gear set up here, and then there's a round gear as well on the actual actuator itself that moves this back and forth. And the lines that you can see on the cast here basically show you fully open and fully closed what that nozzle ring might look like, and shows you the travel capabilities. So if you've got a bus that is, you know, experiencing performance issues and you've got actuator codes, it's possible that there's just a ton of carbon in that nozzle ring area that's preventing that from moving freely, or it's burned out entirely, it's not working at all. But when you take the cover off, you can actually manually move this back and forth, and it should move fairly easily without much force required. And so that's just you know, a small sample of one sort of diagnostic you can perform when you're working on these. I would tell you, don't go and start removing actuators if you don't have insight or a way to calibrate them. Otherwise, you're going to put yourself in a spot where the bus potentially won't operate if it doesn't go back together, you know, exactly just right. So in terms of the turbo itself, there's a couple things about it that can be deceiving, and one of those is if you have oil in the exhaust or the intake side of the turbo, a lot of people will assume that there's something wrong with it, that the turbo has failed, you know, it's going out, it needs to be replaced. And if you've replaced a turbo, you know that it's very expensive to do that, especially if you are out of warranty. But what you need to be mindful of is just because there's oil in the turbo does not mean that there is actually something wrong with it. And the way to kind of identify that is to check your end play and check your running clearance on the turbo itself. And Cummins has all of that available through QuickServe. You can find those numbers. I'm not going to read them off here just for the sake of your time. But those are really the two things you need to look at, is the end play within spec and is the running clearance in spec, and is the actuator operating. If so, really the turbo is fine. There's oil there, but that's not generally related to the turbo itself. It's related to a deeper problem inside of the engine. So what happens with this in many cases is there is an oil drain on the turbocharger that runs back into the crankcase. What will happen if you have, let's say, an increase in exhaust pressure inside of the engine is that crankcase begins to pressurize. And as that crankcase pressurizes, that pressure, that air, that exhaust needs somewhere to go. So it starts looking for a path out. And what it'll do in some cases is start actually pressurizing to the point that it pushes oil up the turbo drain and causes oil to spill out into the turbo itself. I'm not going to get into the consequences of that, but obviously your after treatment filters don't like oil, they don't like fuel, they only like air. And the inverse of that on the front side or the intake side is that your charge air cooler also does not like oil. And you start pushing oil into places it doesn't belong, and it can create a much larger problem. So I encourage people during an inspection, and I'm not saying during every 30 day because you're strapped for time, but every once in a while, take those turbo inlet and outlet pipes off and look and make sure that you don't have oil somewhere it shouldn't be, because it can indicate that there's something going on inside of that engine related to high crankcase pressure. And it could be a plug filter, it could be a plugged EGR port, it could be a bad intake manifold filter, crankcase vent filter is the term I'm looking for. It's several different things can play a part. So again, this just sort of speaks to or shows you an example of some of the things that you might see. You could have potentially even a restricted air intake system. So rather than the crankcase pushing the oil up, the turbocharger is actually using that drain as a straw, if you will. And that could be you have something blocking the air intake, your air intake filter is dirty, and the turbo still needs air in, so it starts trying to find it wherever it can get it from. So if you see this sort of thing, it's again, generally not indicative of a turbo problem. It's an air intake problem or a crankcase pressure issue or something of that variety. So another thing that often gets overlooked, and this one is kind of an interesting one, is your air compressor. You have to keep in mind on the Cummins engine, the air compressor is gear driven. So it is sharing oil with all of the rear gear train components. And for that reason, because it's directly connected to the engine, it is possible that the air compressor itself can actually pressurize the crankcase. So what will happen, and we see this a lot with maybe an older bus, is over time they don't build air as fast as they used to, or it just seems to be slow, it seems to be kind of leaky, it's just not working very well. And what can happen is the discharge line can actually build up with carbon over time. And when that discharge line builds up with carbon, it reduces the amount of space that air has to travel or has to use to charge your air system. But the compressor is still producing the same amount of air, so where does it go? Some of it goes down the discharge line, some of it actually ends up getting pumped into the engine itself, which increases crankcase pressure, which now causes potentially oil, again, to go to places that it shouldn't be. So I often tell people, don't overlook the air compressor as a potential contributor to crankcase pressure problems if all else seems okay. And really what you can do is pull the discharge line off of the compressor. You can look in the tube itself and make sure there's not an excessive buildup of carbon in there. And if you find that there is, clean it out. Maybe that solves your problem, maybe it doesn't, but it certainly doesn't hurt to keep that cleaned out. So EGR valve is probably another one of the more common complaint items. So it's the turbo actuator is a problem, and sometimes the EGR valve. So you've got to keep in mind that we are sending exhaust back through the engine, but it has to go through the EGR valve first, of course, exhaust gas recirculation valve first. That is, really creating a lot of issues potentially, because the reality is all that black smoke that we used to see hanging over the bus yard, all of that carbon, all of those deposits that are still probably on your shop doors or on the wall behind where you parked, that's still there. It's just being kept inside of the engine now instead of being allowed to escape down the tailpipe directly. So all of that carbon buildup will start to potentially build up in your EGR valve. And given the nature of the school bus duty cycle, I'm not going to say there's really any one trick to preventing that from happening, but it certainly doesn't hurt to keep the engines running hot and keep them running at speed. Unfortunately, reality is in a school bus that just doesn't happen. You know, some of us run 20,000 miles a year, some run 6,000 miles a year on a bus, and it just really, it's going to depend on your situation. So if you have an EGR valve that fails, you can measure resistance on it and make sure that it's not greater than 15 ohms, and that will tell you kind of at a quick glance, is this thing functioning correctly, yes or no? And if it's within the correct resistance, your voltages are correct, you you have another issue either somewhere else or it's just plugged in that case. So you can clean it, you can remove it, you can actually go in there and kind of scrape out the deposits that get in there. And that's something that you're probably going to have to do at some point. Just before you do that, make sure you order new gaskets and make sure they're correct before you tear into everything and realize that you didn't order the gasket. Clean around the stem, clean out the carbon to the best of your ability. Again, you're going to have some carbon coating regardless of how old the bus is. You're going to have some buildup there. That's okay. Just really excessive buildup where you can actually kind of chisel or scrape it out of there is what you want to get rid of. Be careful. Don't go in there and start banging it on the bench to try and shake out the loose stuff. Really use a pick and get in there and kind of perform a little bit of surgery to get it cleaned out. This just talks through that, and Cummins has procedures available. I'm not going to explain to you how to clean it, but it is obviously something that can be done and may need to be done. What I will point out is that sometimes you'll have a code that comes up that indicates the EGR valve is not functioning correctly, and that is generally what's going to tell you, hey, I need to clean this thing. In some cases, once you've cleaned it and you reinstall it, if you still have active codes, it's very possible that the valve is just kind of beyond cleaning and repair at that point. Cummins will give you a 4-digit code, but these cross-reference over nicely to the SPN numbers that you're going to get in a health report or off the dashboard. So if you think about the EGR valve itself, again, we talked, we call this SCR training, but again, it's more than that. Why would that cause a failure of your after-treatment system? Really, it is creating a crankcase pressure problem. It's creating an issue where the exhaust has nowhere to go. It pushes oil into places it shouldn't be, and all of that ultimately causes damage to the after-treatment system. And one way that a driver might notice a plugged EGR is a bus that is very sluggish. It might even shift kind of funny. They call in and say, my bus has no power, or it shifts very violently. It is potentially a plugged EGR because the engine is just not breathing correctly and operating the way it's intended to. So going through the exhaust system flow, kind of down the tailpipe here, this is a fairly old graphic, but the principles are the same in terms of the flow of exhaust as we run down the system through the diesel oxidation catalyst, through the diesel particulate filter, through the crossover tube or pipe, if you want to call it that, on the older stuff, then into your SCR. So that system has been kind of modified a little bit over time, and we'll talk about that here in a second. But one of the things that should be understood is the types of regeneration that exist. And the reason that it's important to understand is because they all require sort of different scenarios. Sometimes you're not even aware that it's happening, but you should know that there's different ways to go about it. And so really regen is just collecting soot that is basically, it can't be burned off fast enough, so we have to store it somewhere. And the process of regeneration is basically injecting additional fuel to try and burn off some of this stuff before it goes down the tailpipe, and there's 3 ways that it can do that. So the ideal is passive. That's when the exhaust is hot enough that the driver doesn't even realize it's happening. Nobody is really aware anything is going on. The exhaust is 600 degrees Fahrenheit or higher. In other words, it's hot enough to burn this stuff off without any additional fuel. The driver doesn't have to do anything. There's no lights, all is well. So you think about an over-the-road truck or your sports buses that are running, an hour on I-90 or 87 or whatever. They may be in a passive regen where basically what comes down the the exhaust system is burnt and dealt with as it comes in. So it's sort of one in, one out. Active would be us collecting soot faster than we can get rid of it. So the exhaust system has limitations. You know, we are going to have to collect this soot. It can't be oxidized. It can't be cleaned up as fast as we are receiving it. So what it will do is inject fuel into the exhaust stream to try and create that additional heat. And that's going to happen when the bus is moving, when the bus is stationary, as needed. So you'll see that in a temp light that comes up on the dash. That means that you're in typically an active regen. Of course, stationary is all of our, probably the one we hate the most, because it means that you probably had to get involved at some point and initiate that regen sequence because the bus wouldn't do it itself. We talk with drivers about idling, and you know, it's not just about burning fuel, but it's about the fact that, as I said, that soot, that exhaust is still there. That was always there 30 years ago. We just don't let it escape now. So if they let their bus idle for 30 minutes in the parking lot while they're in the break room having their coffee on a cold morning, it's probably collecting a lot of soot very quickly because the exhaust system is not hot enough to do anything with it. And so you repeat that cycle day after day, and suddenly you start to run into regen issues because of excessive idle time. That's potentially contributing to that problem. So some of the parameters, I'm not going to bore you to death with this part too much, but there are two different ways to go about regen in terms of settings. And it is really important to understand the difference between the two, because the school buses that you run should really all be programmed the second way that I'm going to show you here in a second. I'll kind of explain. So in the ECM, you can control or tell that system when it's allowed to go into a regen. So really, we have to have a minimum speed setting. And the way Cummins is set up, if you are set to anything above 0 miles per hour, basically the bus will not regen until it reaches a speed of 40 miles per hour. I know that can sound kind of complicated, but the idea there is that we don't want that engine to regen while it's sitting at a loading dock, for example. So we want to wait till that vehicle is up to speed on an open road before it's allowed to do any regen. So we have our start threshold, which is the red line here, is at 40 miles per hour. We have our minimum speed setting down here. The blue line represents, say, an average school bus on a morning where you might hit 28, cruise for a little bit, do a student stop, and kind of repeat this cycle of stop and go. What you'll see, though, is that that bus never hits 40 miles per hour all morning. Therefore, it never goes into a regen, an active regen. And that's really problematic because it needs to. It's producing all of that exhaust. It is basically choking on it at that point. So you can see here, regen will start above 40. In this case, once we hit 40 miles an hour, and it will continue down to the minimum speed setting. So this is okay, in some cases, but again, we don't like this for school bus. If you are somebody that's backing up to a loading dock, you don't want to be in regen when you're sitting at the loading dock idling to keep the truck cool. That's kind of why this is designed that way. On school bus side, let me skip down here, we can set it down to a 0 mile per hour speed threshold. And what that does is it automatically basically tells the system to regen pretty much immediately, as soon as it needs to. So what you'll notice is when you're at a stop sign and the temp light comes on, as soon as you hit about 5 miles per hour, it turns off. That tells you that the bus is regenning correctly with a start threshold of about 5 miles per hour, and all is well in the world, and the bus is happy. And it will regen as long as it needs to, and it will regen while it's sitting still. And that's really what we want that engine to do. So going through quickly here some of the system components, I'll just kind of give you a better look here. Years ago, at least on the IZ product, we were using a very large after treatment system, what they called a dual can system. Now we're down to a single can system, which is smaller in size, lighter in weight, and because there's less surface area, theoretically it stays hotter, which is better for it. All the components are still the same. They're just in a more compact kind of package. With the after treatment system, this is something you guys definitely run into as far as warranty goes. Some of the components are supplied by Cummins. Some are supplied by the OEM. And that is because Cummins doesn't know necessarily what the engine's going into, and they are not going to design a system for the other manufacturer. So Cummins will say, here's our part, you provide all of this other stuff, and that's your problem. And what that can do is warranty can get a little funny when certain parts go, because depending on who owns it, who installed it, it might change things. But just recognize that some of the components in the after treatment system belong to the OEM, some belong to Cummins. What really sweetens the deal is when the OEM says, hey, Cummins, can we buy the parts from you? And now they say Cummins, but Cummins didn't install them. So it can get a little bit complicated in terms of parts replacement, warranty claims, that sort of thing. So we've got the 4 sections, the DOC talked about a little bit, DPF, the decomp mixer as they call it, and the SCR or select catalytic reduction portion. I'm going to just kind of give you a quick rundown through all the different parts. Again, you can see the 4 filter sections here. The only thing that I don't have in here is when you are installing clamps on these as replacements, let's say the old ones rot out, there's the hardware on the bottom of that clamp or on the clamp that allows you to tighten it down. Make sure that hardware is facing the pavement. And what that does is it allows it to act as a drain. So what we'll see sometimes is somebody will install that hardware, and because it's easier to access from, say, the side of the exhaust system, they tighten it down there, and now that clamp actually becomes sort of a channel for water and salt to sit. So make sure that it's the fastener portion of that clamp is actually facing the ground so that anything that gets in there can drain out accordingly. A lot of sensors along the way, we know this, and they all are obviously playing a part, but really the idea is, and just like a gasoline engine with O2 sensors, we kind of want to know what's coming in versus what's going out. And that information is what tells us not only what adjustments we need to make in the engine to clean up the exhaust, but is the after treatment system itself doing the job that it's supposed to do. So it's going to do that with temperature sensors, pressure sensors, NOx sensors, particulate matter sensors, and so on. There's a lot going on down there, but each one is playing an important part. So a particulate matter sensor, for example, is measuring soot emissions, and if you have to replace that for some reason, you're doing the module and the sensor itself, but that's reporting back to the engine to say, hey, this is where we're at. You need to clean up your exhaust, open the EGR valve, close off the turbo, whatever it might be to clean that up. That sensor is sending that information. Location is on the tailpipe, and again, it may vary depending on make, model, year, manufacturer, and so on. The NOx sensor, there's an inlet and outlet NOx sensor, and it's just like an inlet and outlet O2 sensor. We want to read what's coming in and then compare notes on the backside and make sure that everything in between that was supposed to happen actually did happen. And of course, the parts people in the world of Cummins have made these sensors 2 completely different types, so you can't just stock one. You've got to stock, one of each if you're going to have those on the shelf. Temperature sensors are important. The exhaust system needs to be able to burn that stuff off effectively, and it needs to be hot to do it. So we've got to monitor temperature throughout the entire system to make sure that it's reading correctly, that everything is performing the way it's supposed to. Let's see here. So the ammonia sensor was for 2 model years only, although I am told with 2027 it's coming back, although not that I want to say this out loud, but theoretically that won't have anything to do with us because we will not see 2027 emissions Cummins engines theoretically in this state for now, but there was an ammonia sensor for a short time. Differential pressure sensor is probably arguably one of the more important sensors on the system around the DPF. And the reason I say that is because it's reading not only pressure on the inlet side, but on the outlet side of that filter. So how does the engine know, or how does the computer know that it needs to go into a regen? How does it know the DPF is full? The only way it really knows that is through pressure. If it sees increasing pressure on the inlet side and decreasing pressure on the outlet side, that's going to indicate that exhaust is not flowing freely and there's some sort of obstruction in the way. And so those sensors work together to basically tell the system, hey, you're getting full, or hey, regen was successful, all is well, the work. All right, so dosing valve is straightforward, spraying DEF into the exhaust stream. I'm not going to get into the dosing valve specifics in this training just for the interest of time. What I will say is there are requirements for dosing, which ties into your SCR system, and it's that you have to have temperatures greater than 392 degrees Fahrenheit at the inlet and the outlet of that catalyst. So if you're sitting there idling for 20 minutes, there's a good chance you're not going to reach 392 degrees Fahrenheit as fast as it wants you to. Of course, you have to have DEF. The DEF has to be warm enough to inject, and you can't have any fault codes. So these are all the things that start to play into it. And just some graphics here. I can share these after the fact if you're interested. Nothing too much to talk about here. So you're probably familiar with the older engines up to 2017 actually purging DEF. And what will happen is the driver will key off, and you'll hear a pump running for about 10, 15 minutes at the most. And what that's really doing is basically purging DEF out of the lines and pouring it back into the tank. That system is no longer used that way. Let me back up here. They did change that for the 2017 and up engines, and a couple reasons for that. One was it was creating unneeded complexity, but also causes issues with short cycling of the key, and I'll talk about that here in a second. So one of the things that is important for DEF is that it's warmed, as I mentioned. So you do have a coolant flow valve on every bus that will feed hot coolant through the DEF tank through lines. And that has to be functioning correctly to warm that DEF, especially, let's say, in the middle of winter. The bus has been sitting for a week during Christmas break, and it comes back. It needs to warm that DEF quickly to get that bus operational again. So this valve has been potentially problematic for a lot of us. The issue that we've seen is that it sticks open, and then you're basically flowing hot coolant through the DEF tank all the time, and it's not designed to handle that kind of heat. It then fails the sensor, which is actually 3 different sensors in one, and will cause pretty serious issues with your after treatment or dosing system. The other problem that can happen is it doesn't open at all, and then the DEF never gets warmed up. It can't dose, and it starts to plug up and have other issues. So they've seemingly worked this out now, but it took a little bit of doing to get it there. All right, so let's see here. So some of the inspection things you can do, again, I'm not going to go through every single one of these, but you can pull the exhaust system apart and kind of look at the inlet and outlet sides of each filter. This is actually kind of an interesting way to diagnose engine problems. And it sounds a little bit counterintuitive, but in a lot of cases, you're probably not going to take this apart unless the engine is performing in a strange way, or you had some kind of after treatment problem. But what you'll see sometimes is, let's say, I seem to be burning a lot of fuel, or I'm burning oil and I don't know where it's going, or I keep having to fill coolant, but I don't see coolant. The worst kind of disappearing fluid is the one that you can't find. Where did it go? It had to go somewhere. And you can actually kind of use these filters as a little bit of an indicator of maybe what's going on inside of that engine. So an example of that is a melted DOC inlet and outlet. And this is your first filter. And what you'll see is the ceramic material is melted away. And this can tell you that there's fuel or oil in that exhaust system. And that is potentially very problematic. Why is there fuel? Is it a leaking injector? Why is there oil? Is there a bad steel gasket somewhere? Is there a crankcase pressure problem? What's the issue? So I'm not going to go through every single image here. There's quite a few, but you can use these as a guide to see sort of what is going on inside of your engine. All of this stuff is available from Cummins on QuickServe, and you can find inspection procedures in the same pictures that I use here. And it's really helpful to take a look at that stuff. So I don't know anybody that's cleaning a DPF every 30 months or 6,500 hours. That's just not happening, but that's what they actually recommend doing. So let me just get through these here, and I got to click through one by one because I can't see what I've got over here. This one's a good example of concentrated white ash on the DPF, and this can be, again, excessive oil. So sometimes, depending on what it is, it might indicate oil or fuel or coolant, depending on the type of staining that you see. And if you know I have a bus that is burning up oil, but I can't find oil anywhere, this would kind of confirm your suspicion that something is wrong. And you all know this, but the answer is not to replace this and hope that it fixes it. The answer is probably there's something deeper in the engine that needs to be looked at. Same here, dark soot ring on the DPF is typically excessive water concentration. So you can see a big difference between excessive oil and excessive water. So it's kind of interesting to see it. Let me keep clicking through here. Let's get that one. So the other portion here is the mixer. There's not really much to talk about with this. It's basically a wall filter that breaks up the exhaust as it comes down and atomizes it so that the DEF is slightly more effective in basically bonding with everything that's coming down the tailpipe. Let me see here. So last stop again is your SCR. We've talked about the DOC, the DPF, and in this condensed version, again, I realize we cover a lot at a very high level, but to give you an idea of what the components are, you can inspect this the same way you do your DOC and your DPF. This is, again, a component that will have some wear and tear and discoloration, but it's a matter of what is normal and what's not. Keeping in mind with the SCR, for example, that you're dosing DEF just ahead of it. So it's very possible that you get excessive buildup of crystallized DEF fluid or diesel exhaust fluid on the face of your SCR inlet. So again, there's several inspection procedures you can look at along the way. I'm not going to go into immense detail because we're 45 minutes in here, but different inspection procedures to become familiar with that are worth your time. Last couple, 2-3 slides here. Operator interface lamps. These are staying the same, model year over model year because they're a standard across the industry. So if you see this DPF lamp on the top here, that usually means that you're running near trouble. It's probably going to be a problem sooner than later, and you really need to increase your duty cycle or perform a stationary regen if this light comes on. It may come with a D-rate potentially. The driver might notice it feels like they have no power or no pep. The high exhaust temperature lamp, of course, is a good thing. My only caveat to that is a high exhaust temperature lamp that is on all the time or with increasing frequency might indicate a problem. And that is where it gets tricky for you guys because you know that, but your drivers don't necessarily know that there's anything wrong. But if that light is on all the time, what that can mean is the system is in an almost constant state of regen. And sometimes that's because the DPF is just too full, as an example. And I kind of explain it like your fire pit at home. If you don't clean the ash out of your fire pit once in a while, eventually it's going to build up to a point where you don't have any space left. And it might, burn some of that ash off the top and clean that top 5% of that filter, but now you're only working with 5% and it doesn't take long to fill it. So you'll start to see this high exhaust temp lamp come on more frequently when maybe the filters are starting to clog or things are getting jammed up and it needs to be cleaned out. Of course, check engine lamp is pretty self-explanatory. Stop engine, same thing. If it says stop engine, stop the engine. You guys know this. I think my last thing here, my last bit of advice, and I found this picture the other day, proudly posted in a group of mechanics online, and I thought this is great, I can use this. DEF handling and care is a really important part of maintaining your system. So as you can see here, they're transferring DEF from one tank to another in the most improper way one might imagine possible. There's 100 things wrong with this picture, but pretty self-explanatory. DEF is not harmful, but it really should not be exposed to air for any reason. It should be dispensed from a pump or from a container, and you know, don't let it sit for too long either. So if you've got a truck that stops and frequently tops off your tank for you, it means that you've got some DEF that may have been sitting there for quite a long time. So you've got to kind of play the game with it a little bit, but just be mindful of how you're handling that. Don't do what you see here, and hopefully that helps you along the way. So that's the very condensed version in the interest of time for you guys having a lot to do and probably driving. Does anybody have any specific questions that weren't covered or something that you would like me to provide you before we call it good?
Does anybody have any questions for Kodie? All right, if you do, if you think of any, please let me know. Make sure Kodie gets them, or you can send them directly to Kodie, and we'll go over them at our next meeting. All right, Kodie. Well, thank you very much for your presentation. Once again, it was full of good information. We will be posting this to our YouTube channel, so anybody who would like to refer to it can, and the people that weren't able to be here today can also get the knowledge. Our next meeting will be held on October 16th. Mickey Jones with BOCES. She presented last year for us on PESHA laws and regulations. And actually, I had a few people ask me if we could do this again this year. So we're going to do this at our next meeting in October. That's October 16th. So if you come up with ideas, or you have a presentation that maybe we did previously that you enjoyed or got information from, please let me know, and we can have this again. We are also going to go over the EV buses. Again, this year, the different changes as we get moving along. But there's still room for some different topics. So if you come up with new topics, please let me know, and we'll make sure that we put a presentation together for you. I'm updating our page as we go along here to make room for the new presentations. Does anybody have anything else to add to today's meeting? All right, not seeing anything. I'm going to go ahead and close the meeting. I want to thank everyone for being here, and we'll see everyone on the 16th.
Thanks, Dan.
No problem.